Namaskar. My name is Sanjay Raju and I'm roll number 57. So here I've implemented my RSA encryption and decryption algorithm. And for this, how RSA works is it takes the message, it encrypts it using a key, which is a public key, and it sends the key to the servers along with its modulo, and the servers can encrypt it and send it back, and the host can decrypt it only if they have the private key, and using the private key they can modulo use, and the modulo the host can decrypt it, and this private key is only accessible by the host. And for the purpose of implementation, and the general working of RSA, the for running it we need to enter two prime numbers, P and Q, and this P and Q, the multiples of it plus 1 will be equal to EQ, and the value of EQ should be less than the value of the public key. That is the general algorithm RSA. So and over here, after the value of public, we can just enter an arbitrary value for the public key, but the value that we enter has to be less than the sum of product of PQ. So let me just run this program and show you key. This generates the public key, private key, and the modulo for us. How this generates it is it initializes a value for the private key as 1, and it has the base value of the public key that we enter, or the default key that it gets, and it iterates through this loop, and it keeps adding one value to the public key, and it divides it from the product of PQ, and since the as long as the value is a float value, as long as the value is a float value, the value that y gets will be the floor value or the base value or the seal value of EQ by x. As long as that happens, the product xy will not be equal to EQ, and once the correct values for the x and y is reached, we get a value that where x and y will be equal to EQ. At that time, we don't need int. What happens is EQ by x will be automatically equal to a correct integer value, not a decimal value, that is equal to y. And this is how you produce a public key and the private key and modulo for the program. So I'm entering the PQ values, which are prime numbers, two prime numbers. So for two prime numbers, two 4-digit prime numbers, I have my Wikipedia open, so I'm selecting two prime numbers from online. So 6067 and 7907. I'm setting a base value for x as 20. We needn't actually enter this value, it automatically generates, but to skip we can enter the value of 20 just to reduce the number of iterations that this loop goes through. It's not needed, but it's better that we do it so that it reduces the time. So we have generated the public key, the private key, and the modulo. Coming to our encrypt and decrypt, I have done the same thing as over here. I'm reading the values from the arguments in the command line. I'm reading the PQ, which is the modulo that we send to the server, which is this value, and we are sending the public key for encryption, and for decryption, which only the host has access to. We're sending it for decryption only. Okay, so let me run this program and show you. Okay, as long as when encryption happens, we take the value, we multiply the message with the key, and we divide it using the modulo. We take the modulus of it using the modulo, and the encrypted message is received like that. So the same function is used for encryption and decryption. So let me run this and show you. RSA and minus PQ, the flag value, so that will be equal to the modulo from the keychain that we generated, which is 47971769, and the keys will be equal to, in case we don't enter any of these values, the program will automatically stop and shows the error that we didn't enter the values. So for the encryption, we're using the public key 4057, and then the setting the process encrypt. We're entering the message 12345, and we received an encrypted message. So this is what travels, and this is the message that a host receives, and they can decrypt it only if they have the private key. So let's decrypt it. So Python 3 RSA minus PQ using the same modulo 1769. It has to be the same value, otherwise there will be error. So for the key, we are using the private key 11821, and we're selecting the process as a decrypt. And for the message, we are sending the encrypted message 05379. Here, as you can see, we have received the decrypted message. So in the background, what happens is it follows the same process, the RSA algorithm. It multiplies the message with the key and takes the modulo and divides it. So that's how you receive the encrypted message. It's quite basically it's a very basic program and easy to implement. So thank you. That's it.